Energy crops are low-cost and low-maintenance crops grown solely for energy production by combustion. The crops are processed into solid, liquid, or gaseous fuels. Fuels are burned to generate electrical power or heat. The plants are generally categorized as woody or herbaceous. Woody plants include willow and poplar. Herbaceous plants include Miscanthus x giganteus and Panaceum purpureum, both known as elephant grass. Herbaceous crops, while physically smaller than trees, store roughly twice the amount of CO2 in the form of carbon below ground compared to woody crops. Through biotechnological procedures such as genetic modification, plants can be manipulated to create higher yields. Costs during the manufacturing process and less water use can only be accomplished by using genetically modified crops. The amount of carbon sequestrated and the amount of greenhouse gas emitted will determine if the total greenhouse gases life cycle cost of a bioenergy project is positive, neutral, or negative. Specifically, a greenhouse gases carbon negative life cycle is possible if the total below ground carbon accumulation more than compensates for the above ground total life cycle greenhouse gases emissions. Whitaker et al. Estimate that for Miscanthus x giganteus, carbon neutrality and even negativity is within reach. This means that the yield and related carbon sequestration is so great that it accounts for more than the total of farm operations emissions, fuel conversion emissions, and transport emissions. Successful sequestration is dependent on planting sites, as the best soils for sequestration are those that are currently deficient in carbon. For the UK, successful sequestration is expected for arable land over most of England and Wales, with unsuccessful sequestration expected in parts of Scotland due to already carbon-rich soils. Further argued that the most successful carbon sequestration in the UK takes place below improved grassland. Solid biomass, often pelletized, is used for combustion in thermal power stations, either alone or co-fired with other fuels. Alternatively, it may be used for heat or combined heat and power, cheap heat production. In short rotation coppice or agriculture, fast-growing tree species like willow and poplar are grown and harvested in short cycles of 3 to 5 years. These trees grow best in wet soil conditions. An influence on local water conditions cannot be excluded. Establishment close to vulnerable wetlands should be avoided. Whole crops such as maize, Sudan grass, millet, white sweet clover, and many others can be made into silage and then converted into biogas. Anaerobic digesters or biogas plants can be directly supplemented with energy crops once they have been ensiled into silage. The fastest growing sector of German biofarming has been in the area of renewable energy crops on nearly 500,000 hay, 1,200,000 acres of land 2006. Energy crops can also be grown to boost gas yields where feedstocks have a low energy content, such as manures and spoiled grain. Small mixed cropping enterprises with animals can use a portion of their acreage to grow and convert energy crops and sustain the entire farm's energy requirements with about 1/5 of the acreage. In Europe, and especially Germany, however, this rapid growth has occurred only with substantial government support, as in the German bonus system for renewable energy. Similar developments of integrating crop farming and bioenergy production via silage methane have been almost entirely overlooked in America, where political and structural issues and a huge continued push to centralize energy production has overshadowed positive development. European production of biodiesel from energy crops has grown steadily in the last decade, principally focused on rapeseed used for oil and energy. Production of oil biodiesel from rape covers more than 12,000 square kilometers in Germany alone and has doubled in the past 15 years. Biodiesel yield of soybeans is significantly lower than that of rape. Two leading non-food crops for the production of cellulosic bioethanol are switchgrass and giant miscanthus. There has been a preoccupation with cellulosic bioethanol in America as the agricultural structure supporting biomethane is absent in many regions with no credits or bonus system in place. Consequently, a lot of private money and investor hopes are being pinned on marketable and patentable innovations in enzyme hydrolysis and similar processes. Grasses are also energy crops for bioethanol. Bioethanol also refers to the technology of using principally corn, maize seed, to make ethanol directly through fermentation. However, under certain field and process conditions, this process can consume as much energy as is the energy value of the ethanol it produces, therefore being non-sustainable. New developments in converting grain stillage, referred to as distillers' grain stillage or DAGEs, into biogas looks promising as a means to improve the poor energy ratio of this type of bioethanol process. In Sweden, willow and hemp are often used. In Finland, reed canary grass is a popular energy crop. Several methods exist to reduce pollution and reduce or eliminate carbon emissions of fossil fuel power plants. A frequently used and cost-efficient method is to convert a plant to run on a different fuel, such as energy crops or biomass. In some instances, torrefaction of biomass may benefit the power plant if energy crops biomass is the material the converted fossil fuel power plant will be using. Also, when using energy crops as the fuel and if implementing biochar production, the thermal power plant can even become carbon negative rather than just carbon neutral. Improving the energy efficiency of a coal-fired power plant can also reduce emissions. In recent years, biofuels have become more attractive to many countries as possible replacements for fossil fuels. Therefore, understanding the sustainability of this renewable resource is very important. There are many benefits associated with the use of biofuels, such as reduced greenhouse gas emissions, lower cost than fossil fuels, renewability, etc. These energy crops can be used to generate electricity. Wood cellulose and biofuel in conjunction with stationary electricity generation has been shown to be very efficient. From 2008 to 2013, there has been a 109% increase in global biofuel production, and this is expected to increase an additional 60% to meet our demands, according to the Organization for Economic Cooperation and Development. The projected increase in use need of energy crops prompts the question of whether this resource is sustainable. Increased biofuel production draws on issues relating to changes in land use, impacts on ecosystem, soil, and water resources, and adds to competition of land space for use to grow energy crops, food, or feed crops. Plants best suited for future bioenergy feedstocks should be fast-growing, high-yielding, and require very little energy inputs for growth and harvest, etc. The use of energy crops for energy production can be beneficial because of its carbon neutrality. It represents a cheaper alternative to fossil fuels while being extremely diverse in the species of plants that can be used for energy production, but issues regarding cost, more expensive than other renewable energy sources, efficiency and space required to maintain production need to be considered and improved upon to allow for the use of biofuels to be commonly adopted. Thank you for watching. Don't forget to please like and subscribe. If you have a topic you would like to suggest, leave a comment.